So let's focus on today and kick things off. We have a fantastic lineup of speakers. We're gonna first hear an amazing duo come up. We have Fraser Harris, who is the VP of product at Fivetran, and we have Tristan Handy, who's the CEO and founder of Fishtown Analytics, which is the group behind DBT. So with that, Fraser, I'm handing it off to you. Take it over.
Thank you. Well, welcome everybody. I'm excited to tell you about the future of the modern data stack today, or the future of automated data integration rather. And go deep into what's new. So let's talk about that. Well, I think it's good to start with what changed. And there's two catalysts for that. The first one being the separation of compute and storage, and the second one being cloud services and applications. And the separation of compute and storage actually all started in 2005 with the C-Store database, which was created by Michael Stonebracker, who was the inventor of Ingress and Postgres. And that C-Store became Vertica, which is a cloud data or a on-prem data warehouse that eventually got acquired by HP. 2011, skipping forward, you have BigQuery. And this actually started back in 2006, so around the same time as C-Store. It was read-only queries as a service. And it featured columnar data storage, Google scale parallel processing, and no persistent cache. And what's interesting over time is that's converged with full SQL support and DML. But that was the first, it started out as a cloud analytics, but now it's become a cloud data warehouse. 2014 happens, and we have Snowflake, the first fully ACID compliant relational database management system with columnar data storage and architected for the cloud with separate compute and storage. And if you actually dig under the hood, it's a lot of those ideas, almost all the ideas from the C-Store paper are how you achieve that columnar efficient querying of columnar data warehouse. And in 2017, a company from a different side, the data lake side, released Databricks. And Databricks is really managed Spark. And it's interesting, the Delta is interesting because it's a transactional, ACID compliant, schema constrained columnar format with schema on write, which if you kind of squint your eyes, that looks like a lot like the object store for a data warehouse. And then fast forwarding a little bit to 2019, just recently AWS with Redshift launched RA3 instances, which was the first time Redshift truly had separation of compute and storage. And all of this was interesting because it's happening on commodity hardware versus the previous generation of on-prem appliances on custom hardware. Now, when we think about these data warehouses, we talk about separation of compute and storage as like the really powerful feature, this elastic compute, this somewhat infinite storage. But why does that matter? And the why is increased concurrency. You can have many queries running simultaneously over the same data sets. And from that angle, it's not actually the compute and storage that's so powerful. What's powerful is a consistent distributed database with a managed or shared managed metadata store. And only BigQuery and Snowflake actually have that, where you can have almost infinitely scalable parallelism. And that's really cool. So you can have completely independent compute workloads running in parallel. And this architecture works only because the queries are read-only. These are OLAP systems. For a transactional system, you can't have that shared metadata store separated from distributed compute or its distributed database layer, or at least until very recently, where there's some new inventions there with the new SQL databases. But it's interesting. That was the actual underlying new technology. And if we look at the trends, this is starting in 2012, just borrowing from Google Trends here. Teradata, kind of the granddaddy of data warehousing. You can see Redshift taking off, and catching up, and then followed by BigQuery and Databricks here. And so really this is showing the rise of the cloud data warehouses is dominating data warehousing. And you might be wondering why Snowflake's not here, and that's because Google hasn't really figured out how to handle snow every December, and so it's a bit of a mess. But if you look at the troughs, it follows the exact same trend line to dominance. The other second major driver is the change in the data sources. So everyone is adopting SaaS applications, and they come with standard data schemas. And what I mean by that is every Zendesk instance is running the same schema on the underlying database managed by Zendesk. And it's the same with Marketo, Salesforce, Zendesk, et cetera. Now, these underlying schemas, they can be pretty obscured behind ugly APIs and have strange undocumented business rules about how to correctly copy them. But with enough dedication, you can successfully replicate the data. Similarly, we also have the rise of file stores and databases that have grown rapidly in the cloud. And the benefit of this is that it massively reduces the edge cases in connecting to them. It's not everyone's custom hardware, custom networking. It's much more standardized. And finally, we have JSON, the rise of semi-structured data. When it was introduced back in 2005 as a convenient human-readable web interchange format, I don't think anyone saw the revolution that it would kick off with the NoSQL document databases. And this meant that the old way of field mapping in previous ETL tools needed to give way to dynamic mapping. Now, here's your obligatory graph of the huge increase in data. We are now measuring things in zettabytes, which is about 1 million petabytes. It's just a mind-blowing amount of data. My only takeaway here is that there's no going back. The data is continually increasing in your organization, and the only way to handle that is through automation. I guess my other takeaway is that colored graphs are much more interesting. So with those two catalysts of changes, separation of compute and storage, and the standardized data, the applications and the stores, we arrive at your architecture, or the old way. Here you can see it starts with an operational database. There's some ETL into a staging area, and then a further ETL. All of these are mapping the data, shrinking the data down so it can fit inside the data warehouse, and then sending ETLing those out into data marts as pre-built aggregates. And then those data marts are how you're exposing out to your end users, exposing out to dashboarding tools. There's a lot of complexity here, many steps, and every one of those ETL steps is custom code, and it's brittle. This is the modern data stack architecture. This is what you get with the separation of compute and storage and those standardized sources. It's simple, huge simplification from the old architecture. We've eliminated many layers and eliminated silos of data. Starting with the ETL, this brittle transformation done in flight is replaced by a complete extract load, and we push transformations down into the warehouse, now done in SQL. Now any analyst can do the transformations. Secondly, we've replaced the physical separation of data with logical separation of data, making your technology stack much simpler. There's only one data store. And finally, data marts are replaced with data models, and these are either views or they're materialized transformations, and your analysts and dashboard users have access now to continually fresh data. The data governance is also radically simpler. Instead, you can now just change permissions to those models, and that's your governance layer. Now, there's two major benefits of this new architecture. The first one being uptime. When your transformations break, your data analysts can fix them and rerun the SQL, instantly fixing your results. The second one is speed to changing requirements. You have all these columns available in that complete copy that you made in the extract load. And so as those requirements change, you can quickly update your modeling. And instead of having to edit Python code or your ETL code, and replay from source. So instead, just update your model, rerun SQL, and instantly you have your new results. And these two things, the uptime and the speed, are the key things that reduce the time to insights from weeks to months to hours to days. This is like a order of magnitude shift in how fast you can operate. And for that extract load layer, there's a bunch of features that you would want them to have. So the first is that it should be really easy. The second is that it must be reliable. And it must be secure with your data, it must be fast, and ultimately it must scale. And these five attributes are what Fivetran offers. And here are all the ways that we do that. We're taking all of these previous things that were done in ETL and we've automated them. Automated type detection, automated field mapping, automated schema creation, automated change data capture. And all of that has within end-to-end idempotency. Now, idempotency is a really important word from computer science. And what it means is you can do the same operation over and over again and have the same result. And why that's important is because data pipelines fail. They fail all the time for all sorts of different reasons. They fail because of network issues, server outages, etc. You have to work around that. You have to be resilient. And so the only way to do that is through idempotency, being able to fail and start again and run the same operation over and over again and get the correct result. The other major features you want are complete schema replication, going back to that speed. And finally, you want pre-built curated schemas so that you don't have to go through the work of figuring out what those underlying, what the underlying data schema is in that source system. Now, let's imagine that you do have that data pipeline. Well, what we consistently hear from data leaders is that their data engineering team is struggling with integration requests. 40% of their data engineering time is spent maintaining existing data pipelines. 40% on maintenance. Does that number sound true to you for your team? And worst of all, that's stopping them from being able to take on the high impact projects to operationalize and productize their data. They're stuck doing that maintenance activity instead of delivering new value. So how are they and you going to scale to the rapidly increasing volumes of data and the rapidly increasing sources of data? And how does your architecture scale? How does your team scale, your data engineering team? You know, these are all really hard problems. Imagine a world of 10,000 data pipelines. In a sufficiently large company, I can imagine that. If that doesn't give you a headache and your mind explode, you know, I'm not sure what will. And luckily, I've got an answer for that, of course. And we call that citizen data integrator. So here's some data analysts at Fivetran. Jessica, she's a marketing analyst, distributed with the marketing team, and she cares about attribution. And here's Carson, a sales analyst, embedded with the sales team, and he cares about attainment. We have Josh, financial analyst who cares about ROI, and Lindsay, a data analyst who works on our pricing, modeling our pricing. At Fivetran, all of these analysts are citizen data integrators. In total, we have 14 analysts, and some of them are distributed in business units like these folks, and some of them are in our core analytics team. But what they all share is they manage their own data pipelines. This data strategy is being adopted by many of Fivetran customers, where the data analysts are the data integrators. And aside, you can see they're all really happy here, big smiles, and that's because they aren't blocked waiting for data in the data engineering queue. They're able to do it themselves. And I can't imagine something that would make a data analyst more happy than that. And we have an architecture to enable this. This architecture leverages the modern cloud data warehouse. So how does it work? Well, starting from the top of the cloud data warehouse, you can see that the distributed analysts are organized by teams based on their business unit. So sales, marketing, product in this example. And each one of them has their own database, a self-service sandbox database where they can bring data into. So at the top, you can see we have the sales self-service database and then marketing and product. Our core analytics team has their own database with the highly governed data models. And the distributed analysts have access to those models through select permissions. So the core team is still maintaining our most important data models, those data models that are shared across the company, and ensure the quality of those shared models, while the self-service distributed teams can do their own work with their own data. And finally, at the bottom, we have a third type of database, which is the restricted data. And this is, in our case, our people operations team can bring in their own very highly sensitive employee data, sanitize it, and then expose those sanitized models through permissions to out to the core analytics team. So what's interesting about this? Well, the distributed analytics teams are bringing in their own data. They're doing their own data modeling, and they're able to expose that within their own team. And this is fully self-service from source to insight. And that's the huge speed improvement. At first brush, you might think that the data governance here is very complex, but there's a neat shortcut that actually makes it very simple. And that's that each distributed team has access to all of the source data. And what I mean by that, let's say I'm a marketing analyst. Well, I have access to our ad system and the data in there. I have access to our email marketing system and the data in there. So by allowing me to bring that data into my own sandbox, I'm not actually being given any additional permissions to data. And we call that transitive permissions. So if I have permission to system A, I should also have permission to that same data in the data warehouse. So the data governance question now simplifies to, do I as an administrator want to give people outside of that team access to that sandbox? And again, there's a simplifying shortcut. You just choose a default. Do you allow access by default or do you block access by default? And once you make that binary decision for your company, everything else is a special case. It's very simple data governance. It's pretty cool. Now you might be wondering how all these data analysts are going to handle transformations and modeling. I've just got an arrow here with ambiguous transformations. Well, let's show you. Today I'm announcing that Fivetran is getting fully on board with DBT. This is bringing a lot of the best practices of modern software development, like version control, reusable code, peer review of code, and testing to the data analysts. And our intention is to help make DBT the standard for data modeling. Firstly, at Fivetran, we've stood up a new team of data analysts, which we call the Solutions Analytics team, who are building out DBT packages for every Fivetran schema. These packages are open source. You can include them in your DBT project and orchestrate it in any way you want. And with just the simple one-line install, you get from these packages staging models, tests, aggregation models. So with a Fivetran connector and a DBT package and a one-line install, you can get from 0 to insight in hours. That's amazing. Amazing for those analysts and how productive they can be now. Secondly, Fivetran can now orchestrate your DBT project. This is an extremely easy setup, starting from the Fivetran dashboard, where you connect Fivetran to your version controlled repository. The only new requirement is this special deployment.yaml file that has configuration and code of the schedule for running your DBT jobs. From there, everything is automated. The full power of DBT, along with all of these pre-built transformations as packages, available to all of your analysts. I've convinced you at this point, hopefully, that Fivetran is really excited about DBT. And a lot of you are probably wondering, what is DBT? It's a good question. Well, I'm pleased to introduce Tristan Handy, CEO of Fishtown Analytics, maker of DBT, who can explain.
Hey, everybody. Gosh, the chat makes me so happy. James says timeline on the QuickBooks package, and literally, I remember I built a QuickBooks package back in May of 2016, and it was horrible. It was the first thing I'd ever tried to do in DBT. So like, time is a flat circle. We're coming right back around to the beginning. James, I could not also be more excited for the Fivetran folks to release a QuickBooks package that is way better than the one that I did. Let me talk about what DBT is for a second. I think that we're maybe just running behind a tiny bit on time, but I'm going to see if I can blow through this. I'm going to do a quick screen share. There we go. Let me see if I can. There, great. What exactly is DBT? It's not actually, I like use this phrase a lot because it's a hard thing to explain. At the most basic level, I copied this slide unashamedly off of Fraser. This DBT is the lines that go from the raw tables to the transform tables from the left to the right. It helps you build derived data sets inside of your data warehouse using SQL. And it exposes what we call a domain-specific language on top of SQL that allows you to express certain very data pipeline specific syntax. And it makes it much more concise to write that type of logic, much more reliable than if you were just going to use raw SQL to do that. This is what we call the analytics engineering workflow. So you can see on the left, there's Fivetran loading raw data into the data warehouse. The next step, everything takes place inside of the data warehouse. The data never has to move anywhere. And dbt helps you go through the process of snapshotting your data when it changes, transforming your data, testing those transformations and the raw data, deploying all of that code to production and documenting it so that you can make sure that throughout your organization, there's a common understanding of what data sets are available to be used. And all that happens on top of a common foundation, version control, alerting, logging, all of the things that you would expect from a modern application. All of that is again, I'm like copying off of Fraser. Fraser talked about the personas here. Who is using this stuff? And I have never had the pleasure of meeting these wonderful folks. They're members of the Fivetran team. But it goes to highlight the critical thing about the modern data stack from front to back is that it is owned and operated by the data analyst. And this is in stark contrast to the way that this work would have been done in the past, where you would have data engineers who are doing work in writing custom code in running it in Airflow, or in a prior generation, you would have BI developers using complex enterprise software to often to point and click and move data from point A to point B. In the modern data stack and in dbt, it is the data analyst who owns the workflow from beginning to end. And that's important because there are just a lot more data analysts than there are data engineers. And so if you really believe that you want this work to be done quickly and agilely, you want to put it into the hands of the people who actually are facing these problems. Also, data analysts are much closer to the business. There's this blog post that I consider gospel back from 2016. It was called "Engineers Shouldn't Write ETL." And the main point with it that the author made was that data engineers love building technology, love building platforms, don't necessarily always want to get into the weeds of how you amortize revenue over the course of the year, how you split cost of goods sold and associate it with the products that are being sold. Those are the kinds of things that analysts spend all their time doing. And that is the core work of data transformation. So you want to empower the people who care about that work to do the work themselves. I don't know why my slide didn't load, but the dbt viewpoint, anyone who knows SQL should be able to author their own data pipelines, and tooling should enable them to work like software engineers. Finally, I'll leave you with this. It's been really, really rewarding for us. We've been building dbt for over 4 years at this point. dbt is an open source product, and we have a commercial product on top of it called dbt Cloud. But we've been now working on dbt since mid of 2016. And I can tell you, like, the individual humans who are like at the very beginning of this curve and have seen what it is that we've been building together, both in the product and the community, and have acted as evangelists and have loved that and made it their own and spread it to the people that they knew. So what you can see here is a curve that is actually people telling people, and bringing everyone along for this new way of working. Because really, dbt is not just a piece of technology; it is a workflow. It is a new way to accomplish this this job, and that requires that we all learn new best practices together. And it's the dbt community where all of that is happening. So if you poke around with dbt as a part of the aftermath of this conference, we'd love to have you join us in the dbt community at community.getdbt.com. And with that, I am going to turn it back over.
Great, that was awesome. Thank you so much, Tristan and Fraser, for kicking off our conference, or sorry, kicking off our day. This has been great. I'm going to ask everyone to close out of this session. We have an executive fireside chat that is going to be beginning in 2 minutes. So Tristan, this will be your chance to migrate over from this Zoom over into the other event in Pathable, and all of us will come with you. So thank you again, and join us in a minute or two. We're going to give a little bit extra time for people to migrate over. We have an amazing executive fireside chat coming up. Talk to you soon.